Let's continue to number 8. Number 8 is about electric circuit and electrical quantities. Figure 8.1 shows 3 cells, each with EMF 1.5 volt connected in series. Calculate the combined EMF of the cells. To calculate the combined EMF, first we have to look at the position of each cell. Here, each positive pole always meets the negative pole on the next cell. See here, this is positive, the next one is negative. From here, positive, negative, and so on. If they are connected in that way, then to calculate the combined EMF, just add all of the EMF together. So the answer for number 8A is 1.5 plus 1.5 plus 1.5. This equals to 4.5 volt. That's the answer, 4.5 volt. Question 8B. Calculate the combined resistance of the 3 resistors shown in figure 8.1. Let's go back to figure 8.1. We have 3 resistors, 4 ohm, 1 ohm, and 1 ohm. The 4 ohm resistor and the 1 ohm resistor, they are side by side, so they are connected in series. When 2 resistors are connected in series, then the combined resistance for the 2 resistors is the sum of the value of each resistor. So, the combined resistance for the 4 ohm resistor and the 1 ohm resistor connected in series equals to 5 ohm. 4 plus 1 equals to 5. So now we can consider that we only have 2 resistors left, 5 ohm and 1 ohm resistor, which are connected in parallel. Now let's calculate the combined resistance for the 3 resistors. We use the equation 1 over Rp. Rp stands for resistor in parallel, equals to 1 over R1 plus 1 over R2. Now we only have 2 resistors left, 5 ohm and 1 ohm, both connected in parallel. So 1 over Rp equals to 1 over 5 plus 1 over 1. 1 over Rp equals to 1 plus 5 over 5, or 6 over 5. Guys, we want to find the value of Rp, not 1 over Rp. So we have to flip the equation first. Don't forget that. Rp equals to 5 over 6, or 0.83 ohm. Limit your answer by only 2 or 3 significant figures. So don't use too many decimal places. Put that on the provided space, 0.83 ohm. This is the answer. Question 8C. Calculate the current in the 4 ohm resistor in figure 8.b. Once again, let's go back to figure 8.b. Here we can see that we have 2 branches, 1 and 2. Each branch will have the same amount of voltage, and it is also the same as the total voltage. The total voltage is 4.5, comes from 1.5 plus 1.5 plus 1.5. So each branch will also have 4.5 volt each. Now, let's look at this branch only, because we want to calculate the current flows in the 4 ohm resistor. The 4 ohm resistor and the 1 ohm resistor are connected in series. So, they both have the same amount of current flowing. If the 4 ohm resistor has 1 ampere, then the 1 ohm resistor also has 1 ampere. That's just an example. That's not the answer. To calculate the answer, we need to add them together first. We have to combine the resistors as 5 ohms. Then we can calculate the current. The current we get from the answer is the current for each resistor in series arrangement. But remember, once again, you have to find the combined resistance for the series arrangement first. Then you can calculate the current. The current you found is the same as the current flows in each resistor in series arrangement. Let's calculate the current now. Remember the formula: V equals to I times R. I is the current, R is the resistance, and V is the voltage. The voltage on the series arrangement is 4.5 volt. We want to find the current times the total combined resistance for the series arrangement is 5 ohm. So I, or current, equals to 4.5 over 5, or 0.9 ampere. This is the current flowing in the series arrangement, which also equal to the current flows in each resistor in the series arrangement. So the current in the 4 ohm resistor is 0.9 ampere. This is the answer. The last question for number 8. Calculate the combined EMF of the cells if one cell is reversed. If one cell is reversed, we just have to change the equation into 1.5 plus 1.5 minus 1.5. The minus 1.5 is the reversed cell. This equals to 1.5 volt. So if one cell is reversed, now the combined EMF becomes 1.5 volt. This is the answer.